Hey, welcome back to day 14 in JavaScript Arrays in 30 days. I want to welcome you back for day 14, where we're going to be working with setting up our own reducer. And by doing so, we're going to be able to continually work with chaining processes that we've been building up to in the last previous days, as you can see with building out our own concat map and a concat all and map and filter. And pretty much what we've done is just from day one on is just taken a imperative approach and went more towards a declarative approach and being able to express what values that we need rather than having to do the imperative, how we're going to do it and what it's going to return to us. So I want to thank you if you're joining me for this day, and I want to jump right on into it. What I want to do is we have yet to have a method that will allow us to go through for each of the items that is in an array and being able to accumulate that together. So the reduce method that's on the array prototype, that will return you a value. But because we're only focusing on arrays, I want to be able to just return an array with that accumulated value. So let's go ahead and just start here. I've already set this up. I'm just going to poke it in a little bit higher. So what we're going to create a reducer method on the array prototype, and what we're going to, there's a lot about it that is just so much just like what you see. Oh goodness gracious! In the reduce method on the array prototypes that you use probably quite a bit these days. What's that? Why did I not? Sometimes reducer. I don't know why it's supposed to. If you hit enter. So we're going to take the function and the initial value. Okay. And then from there, we're going to start working inside of this function. And so it's going to give us our own scope and our own execution context. So that's the important part about this is that because if you watch yesterday's videos, is that we had a lot of scope that was global. So we had variables that were holding on to state that we were having to jump outside of a for each. So we were for eaching over the values in the array and then doing something with those, indexes. I'm sorry, probably the better way to say it. But what we had to do is we had to hold state outside of the for each function. So when we did that is that we lost that closure, and so we kind of went against the functional programming approach to where you don't have to go outside of your closure in order to be able to make changes. Otherwise, you're having a immutable problem. So with that said, we're now setting ourselves up with our closure that's going to allow us to keep all this inside of its own execution context. So one thing we're going to do is we are going to have to hold on to a counter so we can go and make sure that we know what the count is at each step of the way. And we're going to have an accumulated value that we're going to have. Now, before we do anything, is that we have to just do a sanity check and see if there is a length. And this being the array that we're doing, the array that's that we're reducing. So if there's not, if there's nothing there, then if it's an empty array, we're just going to return this. Nothing else to do with it. Else, we're going to then start checking in and seeing what we have. So the first thing that we are going to do is we're going to check and see if the argument's length is equal to 1. And so if we do have the argument's length is 1, Then our counter we're going to set to 1. And then our accumulated value, let me just get some better type in here. The accumulated value is going to be set to this 0. So this is checking to see if there was an initial value that was passed in. If not, just use the first value in the array. Else if the argument's length is greater than or equal to, then the counter is going to start at 0, and then the accumulated value is going to be the initial value that's passed in. Now, if neither of those are right, then we're just going to throw. Just tell them, hey, you're missing your arguments, dude. Okay, now we're going to just continue to loop through this until we exhaust all the values that we can possibly combine together. So here what we're going to do is we're going to do a check and see if the counter is less than this dot length. And if that is the case, then our accumulated value is going to be the combined fn with the accumulated value, and then let's see, the counter. So the counter is going to continually hold on to it. And then counter. So we'll continually increment the counter each time that we run through the loop. So once we've got that, we can then, now that we've got our accumulated value, we can return our accumulated value. So now let's take some numbers here. And let's run our reducer on it. And let's say we have the accumulator and the current. We return accumulator plus the current. And there we go. So we've been able to take the values that are inside of the array, 1, 4, and 8, and drop them down to where we've only got a length of 1. So let me think, and I don't know if it's needed. You know, we can always pretty it up. Yeah. So pretty much what we've done is this is the thing right here is that we're returning the accumulated value in an array. And the reason is that because as we're working through this array in 30 days is that we're really focusing on arrays and nothing else in particular. So, and because we already have the return, a return value from the reduce method that's already on the array, is that we wouldn't have to build this ourselves if that's all we needed. But within this series is that the methods that we are creating, they're uniquely different than the methods that are already there on the arrays prototype. So this one in particular that we'll be using as we continue on, then this one is when we do need a reducer to accumulate all the values into one array, this is what we'll use. So as we move through tomorrow in the next 10 or 12 days, is that we're going to have these methods that we've been building out here, with this concat map and concat all, that we're going to be able to just use these all together and be able to, in a very declarative and easy to read code, be able to understand how it is that we're taking possible complex data structures and returning a values that we are looking for in a easier to read. I think I already said that, easier to read approach. So that's the main basis of that. Now having this reducer available to us is that we're able to go through and loop through each of the values. And then when we do so is that we're just going to go ahead and just recursively call this and add it to the accumulated value, and then return that accumulated value once we've exhausted the counter and any of the values that we have to test against. So that's going to be it for today. We have another method that we have on our prototype that we can work with. So we will return for day 15, I think. Yeah. What's today? Today's day 14. So today we will move past this, and we'll start to use the reducer with some of the other methods that we have with more complex data. So this was a pretty basic example for how we're going to use the reducer, but once we start combining it with the methods that we've already created, we'll start to see how we could take this data and be able to put it into a structure that we need according to whatever the specs are. So I hope this was helpful, and I will see you tomorrow. Thank you.